In geometry, second chapter, 10th standard, we have the chapter named Pythagoras Theorem. You all have heard about this theorem before also in lower standards. Pythagoras theorem is applicable only in right angle triangles. Now what is the right angle triangle? A triangle in which one angle is 90 degree is called as the right angle triangle. Here I have drawn one right angle triangle ABC where angle B is the right angle. As you all know, in every right angle triangle there is one hypotenuse side. Here side AC is the hypotenuse side. Now how to identify the hypotenuse side? The side opposite to the right angle is called as the hypotenuse. अब यहाँ पर angle B right angle है तो AC will be called as the hypotenuse. Now Pythagoras theorem says that the square of the hypotenuse is equal to the sum of the square of the remaining two sides, meaning AC square is equal to AB square plus BC square. Square of the hypotenuse is equal to the sum of the square of the remaining two sides. This is Pythagoras theorem. Let us take one more example. Here I am drawing one more right angle triangle PQR where angle Q is 90 degree. So in right angle triangle PQR, PR will be called as the hypotenuse. So according to the Pythagoras theorem we have PR square is equal to PQ square plus QR square. Or we can also write this as PQ square plus QR square is equal to PR square. In this first example, previous example also we can write the Pythagoras theorem as AB square plus BC square is equal to AC square. Hypotenuse square you can write either on the left side or on the right side. Hypotenuse square you can write either on the left side or on the right hand side. That doesn't matter. Now, the proof of this right angle triangle, in this Pythagoras theorem, the proof of this theorem I will explain you in my next video. Next we come on to Pythagorean triplets. Pythagorean triplets is group of three natural numbers such that the square of the largest number is equal to the sum of the square of the remaining two numbers. One example of Pythagorean triplet is 11, 60 and 61. Now why it comes under Pythagorean triplet? Because of this reason. If you square all the three numbers, 11 square 121, 60 square 3600, 61 square is 3721. Now add the two smaller numbers. 121 plus 3600 will give you 3721, which is equal to the largest number square. दोनों को ऐड किया तो हमें क्या रिजल्ट मिला? ये थर्ड नंबर का स्क्वायर. That's why 11, 60, 61 will be called as the Pythagorean triplet. Let us take one more example of a Pythagorean triplet. 7, 24 and 25. Square all the three. 7 square is 49, 24 square is 576, 25 square is 625. Now what we will do is add the two smaller numbers. 49 plus 576. 49 plus 576 is equal to 625, which is equal to the third number square. That's why 7, 24, 25 will be called as a Pythagorean triplet. Now let's check whether 3, 4, 6 will be called as a Pythagorean triplet or not. So what is the idea? Square all three. 3 square is 9, 4 square is 16, 6 square is 36. Add 9 and 16. 9 plus 16 is 25, which is not equal to 6 square. 9 और 16 को हम लोग ने ऐड किया तो जो आंसर मिला that is not equal to the third number 6 square. That's why 3, 4, 6 is not a Pythagorean triplet. Instead of that, 3, 4, 5 can be called as the Pythagorean triplet. 3 square is 9, 4 square 16, 5 square is 25. Now if you add 9 and 16, what are you getting? 25, which is equal to the third number square. That's why 3, 4, 5 is a Pythagorean triplet. Now there is one formula by which you can find out n number of Pythagorean triplets. In that formula we have three expressions: a square plus b square, a square minus b square, and 2ab. Using these three expressions we can find out n number of Pythagorean triplets, but there is a condition: a should be greater than b. A ka value should be taken as greater than b ka value. Let us take one example. A as say 7, b I am taking as say 2. Now substitute these values of a and b in these three expressions and you will get one Pythagorean triplet: a square plus b square, a square minus b square, 2ab. Substituting the value: 7 square plus 2 square, 7 square minus 2 square, 2 into 7 into 2. What is the answer of 7 square? 49 plus 4, 49 minus 4, 2 into 7, 14 into 2, 28. 49 plus 4, 53, 49 minus 4, 45, and this is 28. So we get one more Pythagorean triplet: 28, 45, and 43. Using these three expressions, we have found out one more Pythagorean triplet by substituting the values of a and b, keeping in mind that a should be greater than b. Let us take one more example how to find out a Pythagorean triplet using these three expressions. Let us take the value of a as say 6, b value I am taking as 4. Again I have kept in mind that a value is greater than b value. Now substitute these values in the expression: a square plus b square, a square minus b square, 2ab. In the place of a will come 6. In the place of b will come 4. Same way here also: 6 square minus 4 square, 2 into 6 into 4. 36 plus 16, 36 minus 16, 2 into 6, 12 into 4, 48. 36 plus 16 will be 52. 36 minus 16 will be 20, 48. So we got one more Pythagorean triplet: 28, 20, 48, and 52 is one more Pythagorean triplet. Now what you all can do is, taking any value of a and b, you can find out a Pythagorean triplet, but keep in mind that a value should be greater than b. Now try this on your own. Take value of a as say 8 and b value as 2 and try to find out one Pythagorean triplet.